Okay, so we are going to take notes on what we're going to call shape Palooza. Basically, in geometry, we have learned a lot about shapes, and we want to go over all of the different types of problems you can see and different ways that we can use these shape properties and shape rules. So, we are going to actually teach several of the problems from the spring break packet. We wanted you guys to try and see what you were able to do, but we do know that it was difficult and some were confusing, so we're going to go through 6 of the problems from the spring break packet. You should be taking notes on this, and that will help you complete the practice worksheet where the problems are very similar. So the first one we're going to do is number 6 from the packet. We said the width of the rectangle QRST is 4 less than the length. If the perimeter of the rectangle is 40 meters, what is the length and width of the area? And we're going to change this a little bit. And instead of doing length and width, we're going to say what is the area of the rectangle. All right, so the width of a rectangle is 4 less than the length. So we learned how to kind of break our sentences down. The width, which we can represent with W, of a rectangle is a key word that represents equal to, and 4 less than the length. We're going to have our length, and we want the width to be less than that, so we're going to subtract the 4. If we also want to draw a picture so that we can see that our width is the same thing as L minus 4, and then we have our length being represented on the other side. So I know that the perimeter of the rectangle is 40. So again, perimeter equals 40. Perimeter is going to be the space around the shape. So I know that I want to have my L plus my L, my 2 lengths, and my W plus my W, which in this case we know that W is being represented by L minus 4. So I have 2 lengths plus 2 of my widths, which is L minus 4, and that's equal to the total perimeter, which we know is 40. Right? So this is using the fact that we know the perimeter of a rectangle is 4 lengths plus 2 lengths plus 2 widths. And here's the key, is translating that first sentence so that we can then substitute it into our original perimeter formula. So now I have 40 is equal to 2 times L, which can't be simplified, and this can be by distributing, so 2W, 2L, minus 8, and I have like terms, so I can combine 2L and 2L. So I have 40 is equal to 4L minus 8. I'm solving for my variable, so I can isolate by adding 8. And 48 is equal to 4L, divide by 4, divide by 4, and I know that 12 is my length. So originally they wanted us to find length and width. So if I know that my length is equal to 12, then how do I find my width? Well, I can substitute it in. 12 minus 4 is 8, and that's what my width is equal to. So length is equal to 12, width is equal to 8, and we changed the problem so that now we're finding area. So how do I find area of a rectangle? That's another formula that I need to know, which is base times height, or sometimes we say length times width. And I know my length is 12, and I know that my width is 8, and so my area is going to be 96, and they give us meters as our unit, so 96 meters squared. So this is a type of problem where we are kind of doing word problems involving our area and our perimeter. And this is specifically tricky because we're not just using the regular perimeter formula, we have to use a slight variation of the perimeter formula. We're substituting things in. Then, once we use the perimeter formula, we have to know how to use those things to find area, and we have to know the area formula. So this is a little bit tricky for that reason. Another word perimeter example that we have is something like number 10. Rich is building a new garage to house all of his Corvettes. His old garage was 20 by 15, so right away you should be drawing a rectangle and filling in the information, 20 by 15. His new garage will need to be triple the size of his old garage in order to fit all of the Corvettes. If the width of the new garage is increased by 15, how much will the length need to be increased by? So, we have our picture. Does it say that I want to triple the size of the area? Like, do I want to triple this 20, or do I want to triple the 15, or do I want to triple the entire garage? I want to triple the entire size of his old garage. So my original garage, 20 times 15, is an area of 300 feet squared. If I triple that so I can fit all those Corvettes in, I want to do 300 times 3, which is going to give me 900 feet squared. That's not what they're asking for. They're asking for how much will the length be increased by. So if my length is the long side, then my width is the short side. So again, what if my length is being increased by what? What is my length equal to? If the new garage is being increased by 15. So my old one was 15. If I'm increasing, old is being increased by 15. If the old was 15 and I'm increasing it by 15, the new garage is 30. So the new width is 30. How do I find the length? Well, I know that area of a rectangle is length times width. I know that the new garage is 900. I don't know what the length is, but I know that the width is 30. So I need to divide by 30 on both sides. And that means that my new length is 30. Is that what they're asking? Find the length. No. They're saying how much is the length increased by. So how much am I adding to the length of the new garage? So my old garage was 20, my new garage was 10, so how do I find the amount of increase? I'm going to do 30 minus 20, so it means that I added 10 feet to the new garage length. Alright, so again, this word problem is tricky because it's having you work with a bunch of formulas, well, with the area formula, but in a more complex way. It's not just saying, here's the length, find the area. It's saying, triple the area, find a new width, find a new length, and then say how much that changed from the original garage. So again, annotating here, drawing a picture is really going to help. The math here is not super tricky. It's just addition and multiplication and subtraction. But without annotating, it's very easy to miss this question. The next example is more of an example where we have formulas, but we are using figures. So number 19 from the spring break packet is a really good example of this. They're saying that a circle with a radius of 7 millimeters is split into 4 equal parts. So we kind of saw this with our pizza problems, but here we have a circle. Oh, that's a perfect circle. And then it was split into 4 equal parts, right? So the radius is 7. So even though they only showed in the figure a fourth of the circle, we know that a radius goes from the center to the edge, so that my radius is actually being represented here by the straight piece, and again, my radius is being represented by the straight piece. So we can get rid of this bad circle. So my radius being 7, and having it split into 4 equal parts. So find the perimeter of the area. So this is exactly like our hot dog pizza. Right? If I want to find just the length of this crust, I need to find what fraction of the whole circle. So the fraction can be found by taking my piece out of 360. So if I have a quarter of 360 degrees, I have 90 degrees, which is 1/4 of the pizza. How do I find the whole length of the pizza? I want to use 2 pi r. So this is my generic formula. But for this case, I know that I'm using only 1/4 and that my radius is, what they told us, 7. So I want 1/4 of 2 times 7 is 14, and then my pi just comes along with the 14. And so I want to simplify. They do want me to leave my answer in terms of pi. So I have 14 pi divided by 4. Is there a number that I can take out of both a 14 and a 4? Yes, I can divide these both by 2. And so I can have 14 divided by 2 is 7 pi, and 4 divided by 2 is 2. So this is the area, or sorry, this is the perimeter of just the arc. This is just the hot dog crust, right? So I have 7 pi over 2. They want the perimeter of the whole figure. So my perimeter, I just want to add up the sides. So I have 7 to 7 is 14, and then this curved piece is going to be 7 pi over 2. So can we combine my terms? No. So we can just leave our perimeter as it is. The number one common error is that we forget the 14. We remember this whole complicated fraction of the pizza, and we find our problem perfectly, and we forget that perimeter is to add up all of the sides, and we forget these two pieces. So do not forget, when you're finding perimeter, maybe you need to trace it with your pencil so that you remember all of the pieces need to add up. They also want us to find the area of the figure. So area of the figure was just like when we were doing dartboards, right? So here we, again, it's the exact same idea of the fraction times the whole, but in this case, instead of talking about 2 pi r, we're talking about the whole being the area, the whole area of the pizza. And again, the fraction is found in the exact same way, 90 out of 360. Which I know simplifies to 1/4 of the pizza, and pi times radius squared is 49. So 49 divided by 4 does not simplify, and I don't need to add anything to this because I'm just finding the fraction of the inside. I don't have to add any pieces together. So my area is 49 pi over 4, again leaving it in terms of pi. And this was millimeters squared because it's an area, and just millimeters because it's a perimeter, right? So this is one example of given a figure, using these formulas, and then also using them in a little bit trickier of a way. Another example where we should be using a figure, and this one we should have drawn a figure. So if we have a circle, which is our 12-inch pizza, and then we're also going to have a pizza box, and the box goes around the pizza, right? So if Andrea is ordering a 12-inch pizza, we know that 12-inch pizza describes the diameter of the pizza, so how far across the pizza goes. The box is 13 inches by 14 inches. We want to know the space that surrounds the pizza. So how much of the box is around the pizza? So this shaded in area. So this one, we have to do work to find our pizza, which is a circle, and we also have to find work for the box, which is a rectangle. So for the pizza, if I want to find the amount of space that this pizza takes up, I know that the formula that I'm going to use is area equals pi r squared. I also know that for the box, which is a rectangle, if I need to find the area, I know it's going to be length times width. So here, my area is pi r squared, so it's going to be my radius. This is a very common error. We see that our diameter, we need to divide by 2 and get my radius is 6. So area equals 6 squared times pi, or 36 pi. That's my pizza. I also want to find the area of my box. My area of my box is length times width, which they told me was 13 times 14, which gives me 182. Alright, so for this, if I want to find how much space is around the pizza, I want to take the whole box, and I want to get rid of this piece on the inside. So I'm basically, again, this is kind of like those hot tub donut problems that we're seeing in accelerated math. You take the big piece and subtract the little piece, and that tells you what's left. So I want to do the box minus the pizza to tell me how much of the box isn't being covered by pizza. So my box is 182, 2. And my pizza is 36 pi. So if they wanted us to leave it in terms of pi, which they don't really specify here, this could be one answer, right? Or they might tell us to put it in terms of a decimal, or for our example here, we're going to round to the nearest whole number. So 182 minus 36 pi actually comes to 68.9. So if I'm rounding to the nearest whole number, I would say 69 inches squared. Okay, so about 69 inches are not being covered by pizza. So it's a pretty big box for that pizza. Alright, a few more examples. Now these examples are where we are comparing different types of the same shape, but we're not actually given any numbers. So it's a little bit easier for us to do problems like the last ones where they tell us length, they tell us width, they tell us radius, they give us a picture. Here, it's very generic, and this can be tricky. So if they give us the radius of a circle, and as soon as I see I don't have a picture, I draw it out. Oop, that's a square. The radius of a circle, and they're calling that circle X, so I label it so that I know which one. X is 3 times the length of circle Y. So here again, I'll label it circle Y so that I know which one I'm talking about. So they're saying Y has a radius. They don't tell me what it is, but I know this circle Y has a radius. I also know that X has a radius, and that radius is 3 times bigger than the radius of Y. So we could say 3R. They want us to compare the ratio of the circumference of the circle. So as soon as I see this word, I want to think, what is that formula? Circumference is 2 times pi times r. So I want to compare circumferences of x and y. And they want me to compare y to x, which means that I want to put y first, then x. So there's a few different ways to do this. You could plug in just the generic examples into the formula here. So my circumference would be 2 times pi times r. And here, for this example, my circumference would be 2 times pi. And in this case, my r is 3r. Right? So I want to compare y to x. Well, is there anything to simplify over here? No. Is there anything to simplify over here? Yeah, I can multiply these things. 2 times 3 is 6. And then I still have my pi and my r. Now, if I'm going to compare these two things, 6 pi r compared to 2 pi r, I want to get rid of all the things that they have in common, because I can just basically divide and they'll go away in both of them. So get rid of those things. Now I just have to compare 6 to 2. And essentially this is a fraction, it's just written in a different way. So if I have 6 compared to 2, I can simplify this. I can take a 2 out of both. So 6 divided by 2 is 3, and 2 divided by 2 is 1. But here's where it gets tricky. My work has x using 3r and y using r, and I did my work, so really 3 is representing the x and 1 is representing the y. And the problem is asking me to put it in terms of y and x. So if I do my work, and this is why it's important that you label your diagrams, if I do my work this way, I have to make sure that I switch it for my answer. So I can say 1 to 3. That's one way of doing it. I think this is kind of tricky for some people because we don't like doing math without numbers. So one other way that I would suggest is pick numbers. Right? So I'm going to do the exact same problem where we're using numbers, and hopefully that's not as tricky. So here I'm going to say, all right, well, I still have circle x and circle y. I know that my radius is going to be 3 times whatever this radius is. So I'm going to pick a radius. I'm going to say, instead of calling this r, I'm going to call this 2. And so if I know that this radius is 2 and x's radius is 3 times as big as 2, then I'll do 3 times 2, which means this radius has to be 6. So now I can compare the circumference of this one, which is 2 pi times my radius, which is 6, and the circumference of this one, which is 2 pi times my radius, which is 2. So here I have 12 pi, and here I have 4 pi. I still can get rid of the pi's because they're the same in both, and so I'm comparing 12 to 4. I can take a 4 out of both, and so I still get 3 to 1. And again, I'm talking about x compared to y, and they wanted it the other way, so I have to flip it. Right? So some of us actually like plugging in these numbers and can simplify it that way. Others of us are a little confused, like, I don't know how to do math with variables, I don't know how to divide by r. We would much rather have numbers and compare numbers. So do whatever works for you. The last example is, again, using two shapes and having them compared to each other. So they're not drawing anything for us, or they don't give us any diagrams, so I should draw them myself. So I have a semicircle. So semicircle means that I have only half of the circle. So I'm just going to cross out half of my circle. A semicircle and a square have the same perimeter. So right away I see the word perimeter, and I'm thinking in my head, all right, what are the formulas for perimeter of a square? Well, I know that I have side, 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 side. So the perimeter is adding all 4 of those sides up, or just saying 4 times whatever the side is, because they're all the same. I also know that a semicircle has a perimeter, which is a circumference, which I know is 2 pi r, but I cut it in half, because I only want half of the circumference. But I also have to add this piece, because it's still part of my shape, and this is what we normally forget. We remember to do this piece, but we forget that the semicircle needs to add this long diameter for the perimeter. So they're saying, all right, here, my diameter of this semicircle is 16. How much is the square? All right, well, if I know that the perimeter is the same, I have to find the perimeter of this semicircle so that I can use the perimeter to find the side of the square. So I say, okay, great. Well, I know that my circumference is 2 times pi times my radius, which is 8. So my circumference is actually 16 pi. That's the whole circle. I only want half of it. So my circumference of the top piece only is 8 pi. But I have to remember, I want the whole perimeter. So this is 8 pi on top plus 16. That's the perimeter of my semicircle, which is the same perimeter as my square. So I know that this perimeter is also going to be 8 pi plus 16. And I know that if this is perimeter, and I'm looking for 4s, I just substituted perimeter. I need to solve for s, so I can divide by 4, divide by 4. 8 divided by 4 and 16 divided by 4, they can be simplified, so I simplify. 8 divided by 4 is 2 pi. 16 divided by 4 is 4. I can't combine, they're not like terms, so this is the measurement of one side of our perimeter, or of our square. Alright, so it is using both formulas for circles and squares and having to know how to use the sides and the measurements of one to find that perimeter so that you can use the perimeter to find the sides. So you're kind of working backwards to work forwards. So hopefully these notes were helpful, and we will be checking them when you return, and use these notes to help you solve the problems from the worksheets. Alright, we will see you back in class.